Here's question 10 from page 177. Consider the quad ABCD on the right. So what we've got a quadrilateral. This side is equal to that side, and this side here is equal to that side. Two pairs of adjacent sides equal means that that is a kite, but they haven't given me any more specific information. What they're asking in A, prove by means of congruence that BD bisects ABC, and ADC. Alright, so they've given us a hint there. We've got to prove it using congruence. So what we are going to try and do then is prove that triangle ABD, this triangle here, is congruent to this triangle here. Because if they are, then this angle is going to equal that angle, and this one will equal that one, which means that line DB does bisect ABC and ADC. So let's look at the information that we've been given. We know that for triangles to be congruent, they have to pass one of four tests. Either angle, angle, side, side, angle, side, right angle, hypotenuse, side, or side, side, side. So we know we've already been given two sides. We know this side is equal to that side. So with one side, we know that this side is equal to that side, and this side is shared. So we're looking at side, side, side. Triangle ABD is congruent to triangle BCD. Oh, sorry, that's a bad triangle. Triangle BCD, and our reason is side, side, side. Easy enough. Those two triangles are congruent. Therefore, we can say that triangle CDB, therefore triangle CDB, angle CDB is equal to angle BDA, and CBD is equal to DBA. And this implies that BD bisects ABC and angle ADC. Our next task, prove that BD bisects CA perpendicularly. So we're looking at proving that this line and this line bisect at a 90-degree angle, and that this line is equal to that line. So we can do this a couple of ways. I think the way I'm going to try and do this is to prove that this triangle is congruent to that triangle. If they are congruent, it means that that CO is equal to OA, so that DB has bisected it. It'll also mean that angle COB and angle BOA are equal, and because they're on a straight line, that'll mean that they have to both be 90 degrees. So again, our cases: side, 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 angle, angle, side, or right angle, hypotenuse, side. I know that CB is equal to BA, when CB equal to BA. I know from my first question that angle CBO is equal to angle OBA, and this is because triangle BCD is congruent to triangle BAD, which I proved in the last question. So now I have a side and an angle. I either need to find another side or another angle. And I have another side. BO is shared. So I can say, therefore, triangle COB is congruent to triangle BOA. And my reason is side, angle, side. Note that we did make sure the angle that we knew was in between the two sides that we knew. Side, angle, side. The angle must always be in the middle. C. State one line of symmetry in the diagram. That's going to be nice and easy. Our line of symmetry is always the longest diagonal in a kite. So our answer there is just BD. Also, we've proved already that triangle BCD is congruent to triangle BAD. So that will be our reason. Triangle CDB congruent to triangle BDA. Next, D. If BD equals 20, BD is 20, AC is 10, so this whole line, 10. Determine the area of ABCD. Alright, well, if AC is 10, then CO has to be 5 because I know CO is equal to OA. I'm going to calculate the area of triangle BDC because I know it's equal to triangle BAD. So area of triangle DBC, half base times height, which is half 20 times 5, which equals 50. Therefore, triangle BAD also equals 50, and therefore area ABCD equals 100 units. Done.